8.6 Solving radical equations. So in this sessions, we're going to solve radical equations, which is not a new session for us because we look at this in elementary algebra course before. So the strategy is, first, you want to isolate one radical terms alone on one side of equation. And then we're going to raise both sides of equation to the power of the index. So you want to raise the power as the same as index. And after we do that and then simplify it, we may end up in solving either a linear or quadratic case. If after we do step 1 and step 2 and it's still the radical term, a radical terms contains in the result equation, then we may need to repeat step 1 and step 2 to completely get rid of the radical in the equation. Now, I want to point out something on this step 2 because a lot of times we do make mistakes on this. When you raise the power, we are raising the power to entire left, okay, and an entire right side. The reason why is this. Take a look at 1 plus 2 is equal to 3. We agree with that, right? If I square it on entire left and entire right, raise the power on the left and raise the power on the right, then there will be 1 plus 2 to the second power and 3 to the second power, which gives us 3 square is equal to 3 square. That is true, right? This is good. But however, a lot of times the mistake is done this way. 1 plus 2 is equal to 3. And in the past, I see that the student tend to raise the power each term. Okay, so that's not what this step 2 is talking about. Raise both sides out of the equation. Because if you take a look at this, 1 square is 1, 2 square is 4, 3 square is 9. These twos are not equal to each other. So therefore, raising the power each term is the wrong way of doing it. So you have to remember, when you raise the power, you raise the power to entire left, entire right. And then we simplify from that on. Okay. So now let's take a look at on the first example. First, I want to isolate the radical term by itself. That means I need to add 25 to both sides. So that will become 3 times square root of 2b plus 3 is equal to 75. Now, I need to divide both sides by 3 because 3 is divisible. So when I divide both sides by 3, that will become square root of 2b plus 3 is equal to 25. Now I have the radical terms alone on one side and a number on the other side. So I got my first step already, right? I isolate the radical term by itself on one side already. So now I'm going to go to the next step, which is raise the power the same as the index. In this case, since this is a square root, we're going to raise the power 2 to the left hand side and raise the power to the 2 on the right hand side. Try to write it the way that I write it down so that you will have you will not make this kind of mistake. So now square root and square, they cancel it out, so that will become 2b plus 3 is equal to 25 to the second power, that is equal to 625. We ended up in linear equations. So solving linear equation is basically isolating the variable by itself. Therefore, we subtract 3 and then divide by 2. So when I divide by 2 to both sides, that will become b is equal to 311. This is another type of equation that you really need to check your work. So now I'm going to be using the help of the calculator, plug it in this 311 into this original equation and checking it. So 2 times 311 using the calculator, that gives me 622, plus 3, that will give me 625. Now what we do is we take the square root of this value, square root of 625, that gives me 25. So 25 times 3 is 75, and take away 25 give me 50. So 50 is equal to 50. So you may use your calculator to check that, right? And when the number is large. When the number is small, you can check it what? Mentally. So let's move on to the next example. So first we're going to isolate the radical by itself. So it'll be square root of 2r minus 3 is equal to minus 5. Now I'm going to raise the power to both sides, the same as index. In this case, my index is 2, so therefore it will be raising power 2 to both sides. So this will look like square root of 2r minus 3 quantity square equal to negative 5 square. Square and square root cancels it out, so it will be 2r minus 3 is equal to positive 25. Again, we are solving linear equations, so therefore add 3 to both sides, which is 28. And then divided by 2, which will become 14. And we need to check, right? Because this one I checked already. We need to check. Plug it in 14 into original equations. So 2 times r, so that means 2 times 14, that gives me 28. Take away 3, that gives me 25. Square root of 25 is 5. And 5 plus 5 does not equal to 0. So what happened is the only solution that we have right now is not satisfying the equations. Therefore, this is no solution. If you remember the conceptual part, then we can basically tell the answer from that step on. Because square root of a positive number must be only a positive outcome. So therefore, square root of 2r minus 3 cannot be equal to a negative number. That statement is already contradicting. So therefore, if you remember the conceptual part, you can conclude from that step right away to say no solution. A lot of times we will do it systematically. So therefore, you need to check for sure. Okay, don't forget to check. Continue on the next example. Square root of x minus 2 plus 2 equal to x. So let's try to isolate the radical term by itself. So it will be square root of x minus 2, and we subtract 2 to both sides, so it will become equal to x minus 2. Now raise the power to both sides, the same as index. In this case, square root, so the index is 2, so we raise the power 2 to both sides. So this will become entire left, entire right. You will be raising the power. Square root of x minus 2 square. Square and square root, they cancel it out, so it will become x minus 2. Equal to, on the right hand side, you have to be careful because for this part, either you split it out into 2-factor and FOIL it, or you use the shortcut formula So first minus last square, which is first square minus 2 times first time last plus last square. Okay. So you either FOIL it or you either use a shortcut formula to simplify that. So now I would like to use the shortcut formula. So this will become first square minus 2 times first time last plus last square, because that is faster for me instead of foiling. But if you are more comfortable with foiling, always do that on a side work. Okay, and then write it back the answer. So this will be x times 2 and then 2 squared. So that gives me x minus 2 is equal to x squared minus 4x plus 4. Now we are solving quadratic equation because the variable the x has the exponent 2. How do we solve quadratic equations? Set one side equal to 0. So that means I'm going to subtract x to both sides. That become 5x, negative 5x. And then I add 2 to both sides. That become plus 6. Once we get that, then we're going to factor completely and use zero factor property, which is x minus 2 and then x minus 3. The zero factor property say that x minus 2 can be equal to 0, x minus 3 can be equal to 0. So therefore, I got x is equal to 2 or x is equal to 3. Finally, don't forget to check. If I plug it in 2, right here, so 2 minus 2 is 0, so therefore 0 plus 2 is equal to 2. That is good. So we got one solution, 2. Now I need to check for 3. So when I plug it in 3 to original equations, 3 minus 2 is 1, square root of 1 is 1. 1 plus 2, that is equal to also what? 3. So therefore 3 is also good. So in this case, we have both solution is okay. Now, let's move on to the next example. First, we're going to isolate the radical terms alone on one side. So that means square root of m plus 9, I add both sides m. So it'll be m minus 3. Now I have the radical term alone on one side already. I'm going to raise both sides to the second power, which is the same as the index. So this will look like square root of m plus 9 quantity square equal to m minus 3 square. On the left hand side, square and square root, they cancel out, so it will become m plus 9 equal to, on the right hand side, I'm going to use the shortcut formula, which is first square minus 2 times first time last plus last square, which is m 3 and 3 square. That gives me m plus 9 is equal to m squared minus 6m plus 9. Now we are solving quadratic equation, so I have to move everything to one side and then the other side equal to 0. So to do that, first we subtract m to both sides. That gives me minus 7m. When we subtract 9 to both sides, they cancel it out. So now factor completely, factoring out the GCF m, the greatest common factor m, that'll give me m times m minus 7. Using zero factor property, now I can say that m is equal to 0 or m minus 7 is equal to 0. So therefore, I have two possible answers. So what we need to do is we need to check. When I plug it in, 0 into my original function equation, 0 plus 9, that is 9. Square root of 9 is 3. 3 minus 0, that is a positive 3. So a positive 3 cannot equal to negative 3, so therefore this is not a good answer. So 0 is not a good answer. Now I need to check 7. When I substitute 7, that will be 7 plus 9. That gives me 16. Square root of 16 is 4. 4 minus 7 give me negative 3. So 7 is a good answer, and I only have one solution for this case. So from this point on, I hope you remember to check every single solution. Continue to the next example. Sometimes you will get the radical equations in terms of rational exponent, which we need to remember how to rewrite it. So 4x minus 3 to the 1/3 power, this is equivalently saying cube root of 4x minus 3 plus 8 equal to 5. To solve the radical equations, first I need to isolate the radical by itself, so we subtract 8 to both sides, negative 3. Since the left-hand side is a cube root, we know that from the concept, cube root of a positive number will be a positive result, and cube root of a negative number will be a negative result. Therefore, it is perfectly okay to have cube root is equal to a negative number. So now we're going to continue solving as strategy, meaning we isolate the radical terms already, so therefore we raise the power on the next step. In this case, the index is 3, so we raise the power 3 to both sides. So this will give me cube root of 4x minus 3 quantity to the 3rd power equal to negative 3 to the 3rd power. Cube root and 3rd power, they cancel it out, so it will become 4x minus 3 is equal to negative 27. Now, solving linear equations, I add 3 to both sides, that will become negative 24. Divided by 4 to both sides, that will become negative 6. Checking it, when I plug it in negative 6 into either the original equation or this equation, right? Because these are the same. Plug it into it. So 4 times negative 6 is negative 24. Negative 24 minus 3, that will give me negative 27. And we know that cube root of negative 27 is negative 3. So therefore, negative 3 plus 8 give me 5. And that makes it a good solution for us. Sometimes you will have radical terms on both sides, like in this case. This is still not a complicated case because we only have one radical terms on the left-hand side and one radical terms on the right-hand side. So this already isolate a radical term for us on one side. So the next step is raise the power same as index. So we raise the power 3rd power to both sides. So this gives us 5x minus 4 is equal to 2x plus 5, which ended up in a linear equations that we can easily solve. Subtracting 2x on both sides, adding 4 on both sides, finally divided by 3 to both sides. So now we got our possible answer 3. What we need to do is check. So when I substitute 3 into it, 3 times 5 is 15. 15 minus 4 is 11. So we have cube root of 11 on the left-hand side. When I plug it in 3 to the right-hand side, that will become 3 times 2 is 6 plus 5. That will become 11, cube root of 11. So therefore, right-hand side and left-hand sides are equal. So therefore, 3 is the final answer for this problem. Moving on to the last two examples, which has multiple radical terms on each case. So, as usual, the very first step is you want to isolate one radical term by itself on one side. So that means square root of x minus 3, I will subtract square root of x to both sides. So that will become 3 minus square root of x. Doesn't really matter which radical term you want to isolate it. So now the next step is raising the power the same as index. So since this is square root, I raise the power 2. So this gives us square root of x minus 3 quantity square is equal to 3 minus square root of x quantity square. On the left hand side, square root and square, they cancel it out, so I will get x minus 3 equal to, on the right hand side, I will use the shortcut formula, so therefore it will be first square minus 2 times first time last plus last square, which is 3 square root of x square root of x. Simplifying further, that gives me x minus 3 is equal to 9 minus 6 square root of x plus x. Notice that we still have a radical terms in the resulting equation. Therefore, we need to repeat step 1 and step 2, meaning I need to isolate the radical term by itself, then raise the power again to finish this problem up. So it's not difficult, but however, it's a longer process. Now, let's isolate the radical term by itself. So first, I'm going to subtract x to both sides. That gives me negative 3 is equal to 9 minus 6 square root of x, because both of the x is gone. Then I'm going to subtract 9 to both sides, which is negative 12 is equal to negative 6 square root of x. We will divide it by the coefficients of the radical if only divisible. Since negative 12 is divisible by negative 6, we're going to divide both sides by negative 6. That'll give me 2 is equal to square root of x. So now, if I raise the power to both sides, okay, I isolate the radical terms alone already, so I'm going to raise the power to both sides, 2, which gives us 4 is equal to x. And what do we need to do? Check. 4 minus 3, that is 1. Square root of 1 is 1. Plus square root of 4 is 2. 2 plus 1 is equal to 3. So therefore, this is my final answer. Let's take a look at on the next example. Very similar. But however, for this example, it makes it a little bit easier for us because the radical term on the right hand side is alone by itself already. So therefore, we can right away raise the power on the left and raise the power on the right. So this will become square root of x minus 1 plus 2 quantity square is equal to square root of 2x plus 6 square. On the right hand side, square and square root cancels out, so it will become 2x plus 6. On the left hand side, I'm going to use the shortcut formula, so it will be first square plus 2 times first time last plus last square. So it will be square root of x minus 1 square times with plus 2 times square root of x minus 1 times 2, and then 2 square. Simplifying this, Square root and square, they cancels out, so I will left with x minus 1 plus 2 times 2 is 4, so it will be 4 square root of x minus 1 in the middle term plus 2 squared is 4 equal to 2x plus 6. Now we notice that the resulting equation still contains the radical symbol, so we need to repeat step 1 and 2, which is first isolate the radical term by itself, second raise the power the same as index to clear the radical. Simplifying a little bit, negative 1 plus 4 is plus 3 plus 4 square root of x minus 1 equal to 2x plus 6. Isolating the radical term by itself, so first I'm gonna subtract x to both sides. That become x plus 6. Then I subtract 3 to both sides. That become x plus 3. Now, unlike on the previous example, notice that this factor negative 6 and then factor the negative 12, they are basically what? Divisible. But however, in this example, when we divide it by 4 to both sides, it will end up in fractions on the right hand side, something like this. So it is not a good idea to raise the power with the fractions. So therefore, I'm going to just raise the power both sides without dividing it. So this will become raising the power to the left hand side and raising the power 2 to the right hand side, which is 4 times square root of x minus 1 is equal to x plus 3. Using the shortcut formula, the right hand side will become first square plus 2 times first times last, which will give me 6x, plus last square, 9. On the left hand side, using the properties of exponent, 4 to the second power times with square root of x minus 1 to the second power, which gives me 16 times x minus 1 equal to x squared plus 6x plus 9. Now this makes it easier for us to simplify, which is distributing. That will be 16x minus 16 is equal to x squared plus 6x plus 9. Solving quadratic equations is isolating the variable, one side equal to 0, so therefore it will be 0 equal to, subtracting 16 on both sides, 16x on both sides, that will become minus 10x. And then adding 16 on both sides, that will become plus 25. When I factor this, it will be perfect square trinomial, so therefore x minus 5 and x minus 5. And which allow us to get our solution, possible solution, x minus 5 in this case. Checking the answer, plugging 5 into the original equations. 5 minus 1 is 4. Square root of 4 is 2. 2 plus 2 is equal to 4. On the right hand side of equations, 2 times 5, that is 10. 10 plus 6, that gives me 16, and square root of 16 is 4, so therefore they are equal. And finally, I can conclude that 5 is my final answer. And this concludes the section.